Climate change are natural and managed tropical peatland. I'm sorry because time is again limited, so have no chance to introduce the biographical backgrounds of Brukum Pite. Maybe then you can give a summary briefly. Thank you. The time is yours.
Thank you, Chairman. So very good afternoon back from a very good lunch. This being a Friday, I've kept slides on the science, on the deep science to the bare minimum. But I will be showing some of those raw results that are impacting the type of interpretations we are making. To just give you a feel of how from framing the questions we have gone into taking certain types of approaches which have led to outputs which will be of value to policymakers as well as managers of different types of land use. My name is Sanjay Swarup. You see the affiliations are from the National University of Singapore. One of my affiliations where most of the time goes is the National University of Singapore Environmental Research Institute. So this work is being coordinated through that institute. There are other institutes where we do some of the other types of molecular analyses. With that, I start. My introductory remarks are going to be rather short. I'm going to talk a little bit about the institute in one or two slides. I will then bring about some of the characteristics of peatlands. We have been hearing about the importance of forestry and peatlands, forests and peatlands with regards to climate change scenarios in Indonesia. So I will not be introducing the importance of these types of ecosystems. Then I will go into the research questions, and that will be the major part. So the NUS Environmental Research Institute, the vision is to be a global institute for interdisciplinary research. So the key word highlighted here is interdisciplinary. Things that cannot be handled at department or faculty levels are taken up by this institute. And we are involved in research education and transfer and exchange of expertise. The research teams you see as the small core boxes at the bottom. Environmental surveillance and treatment. We also look at the human health aspects, green chemistry and sustainable energy, and the most recent area added is on climate change, looking at both local and regional scales. In terms of speaking, when we talk about the regional scale, we have a number of vulnerabilities and risks associated with various activities in Southeast Asia. That's the regional scale I'm talking about. Coastal ecosystems, land degradation, food and fiber and biodiversity are documented as being highly vulnerable in this region. There are different talks all throughout this symposium on these different aspects. Water resources and settlements, you will be seeing peatlands are one of the biggest freshwater reservoirs in the world, and they have human settlements as well, a small part of this ecosystem. So what are peatlands? In their natural state, these are waterlogged, that's the origin. They have to be in low-lying areas with low pH, nutrients and temperature. Yet they maintain a very high diversity index both for the woody trees, for the herbaceous plants, for the large animals and for the microbial activities as well. As you see, the freshwater resource, they are deep in Southeast Asia compared to the temperate peatlands. The tropical peatlands can go as much as 50 meters down, therefore they are very high and large reservoirs of carbon, and so their role as carbon sequestering parts of ecosystems are very, very critical. So you have both water and carbon associated with peatlands. So any disturbance to that upsets the water and carbon aspect of the ecosystem. Our work is focused in Indonesia because Indonesia, as you see here, has got about 69 gigatons out of the Southeast Asian 89 gigatons of carbon in peatland. So it's about 84% of peatlands of the carbon sequestered is in Indonesia. What you see here at the bottom left is a low-lying area where peat starts accumulating due to waterlogging, and that's how in the end you see a dome associated with peatlands. This is in the natural state. What you see here is a land use change pattern over last few decades. So this is a recent past, right? You see here in Sumatra and Borneo Islands, if you focus on the right side, the grayed out zones in Sumatra and the left portion of Borneo, I hope I can try to point it out. Okay, so these gray areas, and on Sumatra on the eastern side. From that till 2010, you see the blue and red regions where all plantations come up. And in these plantations, you see that the change has happened from a pristine peatland for these two major types of plantations. Okay, this is the light box. Okay. So this is a huge change in plantation because of the plantation's commercial activity, and there are lots of numbers which are out there in the literature. I won't be going through that. What I'm going to show is this small part of Jambi district where we are operating, and this is a blown up portion of that, where Burbak National Park, I'm not going to report any data from there, but these two places, Parit and Pitale, lines that you see, actually view them from satellite images, and these are the channels that are used to drain peatlands. We have mapped all the land use types in this area, in this study area, and all the area around it. So this particular area is about 45 square kilometers. The reason we have picked this area is because it gives us different contiguous land use types. So starting from forest all the way, you will see in the next slide, where this is the secondary forest, where they have been planted, things that have been cut down and burnt and left for a number of years, between 5 to 10 years typically. And you can still see some stubbles of large trees there behind. These are left for a long period of time, and then plantation comes up, oil palm plantations or acacia. In this particular study site, we are on oil palm plantations. There are also settlements which we have seen on these plantations, and then mixed crop plantations. So you have, in terms of the planted areas, you have two types of planted areas, and in terms of land, degraded land, you have settlements and degraded land here, compared to the forested region. So I show you some data to establish the fact that one of the ways in which peatlands are behaving due to this drainage is leading to their oxidation and therefore subsidence. So what I show here is a 1 year period, and over this 1 year, on one side you will see this is the subsidence, which is in terms of the depth of peat, where you dig in a simple stick which is got a marking measurement, and every month you can go back and see how much new measurement becomes available. That can happen due to two reasons. One is through compaction, and the other is through oxidation, biomass oxidation, right? So there are other reports of our collaborators who have established that the compaction contribution to this subsidence is less than 10%. So the major reason why peat is subsiding is due to peat loss. I'll refer you to other papers if you contact me. And so this is in millimeters, as you can see over a 1 year period it has come down. That's one part of this story. The other part is this water table. So as you can see, at the time of high water table, high rain, you will see a subsidence rate has a certain slope. But notice that when you have low water table in the drier times, you have a higher subsidence rate. You see this lower water table, and the subsidence rate slopes becomes more acute. You see it here again. the subsidence rate increases, and so the slope becomes steeper. What this shows is that although hydrology and removing of the water does affect peat subsidence, but I want to highlight another aspect of this plot, which is in these three circles. So if you see here, water level is low, but peat has in fact subsided. But if you look at water table high, even there peat has subsided. Okay? So even with high water table, with hydrological interventions, you are unable to slow down peat loss. Okay? It is slowed but not stopped. So if peat has to be restored, one common outcome of this study has been that you need some additional measures. So the rest of the talk is what are those additional measures. So hydrology alone will not stop peat oxidation. And what we are seeing are three aspects or three types of outcomes of drainage and degradation. One is that when the peatlands are going down because of peat loss, the root structures of these plants are going to be exposed, as you see here, right? So here is a tree, an oil palm tree, which actually has all the roots and it's beginning to topple over. In fact, it has died. The second thing is about increased flooding. As you see peat loss, it's already in a low-lying region, and as peat is lost, it subsides, and therefore its ability to accumulate water is now in a bigger region, and therefore you have increased flooding risks in peatlands. This is the second. The third outcome is because of drainage and deforestation, the basis of peat loss is due to microbial oxidation of peat biomass. So peat biomass is going off as oxidized carbon, as CO2 into air. So this has greenhouse gas effects and radiative forcing effects, which affects climate change, which is a part of climate change. And so peat over a number of years, it used to be a net carbon sink, and therefore I have mentioned that it was a peat which had sequestered carbon. But over a period of time, as I mentioned, CO2 is coming off, and here are some numbers and estimates. But that's one loss in the air, and the other loss is in the fluvial way in which carbon loss is occurred through the river and the drainage system that's been created. So there are these two sources have in fact together led to becoming a net carbon emitter of carbon on the degraded peatland. So from a net sequestering to net output agent of carbon. So part of our studies has been also to look at how the anthropogenic activities, for example, the kinds of salts and minerals which are present in those peat sites with different land use. I showed you at least 5 different land use types. They are affected by the different things, the ions and the metals and the carbon that is present there. So what you see here is a plot of all the different land use types plotted for their microbial fingerprint. So using molecular microbial signatures of their DNA fragments, you can profile and see which type of peatland is different from which another type. So here you are seeing all these 5 different land use types segregated here on a 2D plot. And these eigenvectors, these are lengths of projected influences that different environmental or anthropogenic factors have on the state of these different peat. For example, in these type of green square boxes which come from the plantation areas, nitrate seems to be the most associated factor, and which is understandable and explainable by the fact that lots of nitrogenous fertilizers are used in peatland management. So this in a way gives us a method on how you can see association of land use types and environmental or anthropogenic factors. So similarly, you will see the dissolved organic carbon associated with these mixed crop plantations, and I'll come back to this. And similarly, phosphates are another long vector, which are also due to peatland management for plantation purposes. You will see that when plantation owners and the management practices are such that these nitrogen and phosphate fertilizers are not done according to optimal levels, they are at very high levels. And you will see these white swords being added at the base of all these oil palm trees. So there is an overuse of these inorganic fertilizers, which explains these long vectors. And of course, carbon utilization from the land is an essential feature which we expect to see. So you see a heavy influence of management practices coming out through these analyses. This gives us a way to quantify what is happening in those peatlands. Here, I'm not going to go into details. This is a very detailed, what is known as a metagenomic
Mr.
study.
Sanjay, I'm sorry, you still have 3 minutes left. 3 minutes.
Yeah.
Thank you.
Thank you. So we have these three types of metagenomes from forest, plantations and degraded land, which gives us an entire consortium of microbiome that is present in these sites. What might not be clear, but these are the metabolic capacities of the microbes in the different forested, plantation or degraded lands. So in a way, we are now able to identify what metabolic capacities and microbial changes have happened as a result of land use change. So these markers provide for determining the terrestrial health, as you might say, to follow responses for practices and to develop sustainability indices, because we can easily distinguish microbiome and metabolic potential of forest and degraded peat. So these are some of these solutions that we are now working towards. Biostimulation for reforestation. The good microbes based on the microbiome information can now be taken out of context, increased in capacity using waste from peatlands. The methods can be available at local scale and therefore be used for helping in restoration projects with the different initiatives in Indonesia. The second is to enhance the carbon and nitrogen sequestration, which can be done using similar technologies. So these plants and microbes of high value will help in economic empowerment at the local, very ground level scale. So here's one example in which some of these markers are going to be used. We are in touch and I'm part of the ICCC to look at the microbial and metabolic markers for the National One Map initiative to distinguish different types of peatlands. So these are the types of classification one will be able to do based on these new scientific methods. I am not going to talk, this is the last, perhaps my slide, on looking at some of the climate process drivers which I have not included in this talk, is to look at how that peat oxidation is giving off the CO2 and in fact nitrous oxide as well. So the microbial basis of some of these carbon emissions are now available, we have now done those studies. So these will explain how precipitation and temperature change when working with people on the climate change aspect. There's an aspect of food security because palm oil plantations can be interspersed with these fruit crops and small herbaceous food crops. And that's one of the recommendations we have. We conduct workshops in Jambi with the local village people and the managers, the middle level managers in these districts. Some of these photographs from the team working with the people here are plantation people. At the institute we have village head where we stay in the village head is kind and gracious with us. And with that I am. Thank you.
Thank you, Dr. Sanjay Swarup, for nice and excellent presentation. Maybe we need to proceed to the next presentation.